this crazy experience, and I've learned a huge amount. And today we're going to talk a little bit about why we did the project, some of the science behind what's going on with corals, and then more importantly, a lot of the takeaways that I had on this experience, and I think how that applies back to you guys. So without further ado, this is what I fell in love with as a kid, these ecosystems. Corals, I think to most people, are quite boring. They don't move, they sit on the bottom of the ocean, they're pretty colorful, but they're not fish. They're not the things that everybody enjoys. They're not the whales, they're not the dolphins. I know all of those things are incredibly cool, but my thing was corals. And we actually got an email. That's how this entire project started, was 2 images. And within that email was this picture. This is a really healthy coral reef ecosystem in Australia. This is why we go diving. This is why we become marine biologists. This is what you're supposed to see when you go underwater. And the second image attached was this. And this is a reef that's been absolutely decimated by humans, whether that's temperatures, whether that's overfishing, whether that's nutrient runoff coming from our rivers. This is what many of our reefs around the world actually look like anymore, instead of this. And that's a huge shame. And what we wanted to do with these 2 pictures was, our idea was, I want to document the transition from this to this, and be able to show that to people. And the director of the film actually made a previous movie, and that's where this idea came from. And that was called Chasing Ice, where we actually talked about glaciers. You can imagine, none of us want to go sit on a mountainside in Greenland and watch ice melt for 9 years, right? That does not sound like fun. I want nothing to do with that. But when you can take that 9 years and put it into 30 seconds, that actually makes a really big difference, and it allows our small attention spans, because we're hooked to our phones, we get all of our information in little 30-second bits all day long, and we're bombarded with it. It's really hard to talk about science unless we can fill that 30 seconds with something really cool. So what we did, I was in charge of designing the cameras that did just that. I put them inside this glass dome, and these cameras essentially go underwater, and once a day they wake up and they go boom, 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 and they take 30 pictures. And over a month's time, I'm able to watch the ecosystem degrade, essentially. Now, before we get too much farther into that, I want to talk a little bit about the biology of a coral. So this is a close-up of a particular coral species, and what you kind of see here on the left-hand side is, do you see kind of like the speckles? There's a pattern on the coral tissue. And what that is little tiny algae that live inside of the coral. In fact, if a coral were like you and me, we would probably be green like an alien. Let's say we have, my bad. Let's say that we have algae inside of our skin. If we were a coral, we actually would never need to eat. Instead of having your lunch break, we would all go outside and sunbathe for a few hours, and that would be your meal for the day. They provide 80% of the energy for the coral, and that's how they function. I think that would be pretty cool if we never had to eat, but unfortunately we're not like aliens. However, these little algae cells have sort of a catch. When the water gets too warm, these algae cells freak out. They start producing really nasty molecules, and the corals essentially say, oh man, I'm in big trouble, I have to get rid of this. It's actually very similar to getting sick. Let's say you get food poisoning. Your body recognizes, hey, I've got something inside me that's really bad, it's hurting me, I have to get rid of it. And we throw it up, get rid of it, get it all out. Corals are actively doing the same thing. The corals recognize this algae is hurting me, I have to get rid of it, and they spit it out. And when they spit it out, they end up looking like this. This coral is actually still alive, but it doesn't have its energy source anymore. It can't sunbathe anymore, and essentially it's starving to death. And you can actually see the little bits of algae at the top. That's where the coral is already beginning to die. And so, in a gist, this scientific process of coral bleaching is what we were trying to show the world. And I ended up putting these cameras all over the world. And originally, I failed a lot. In fact, the cameras didn't work the first time, and then the second time we put them in the water, it was because of this data set. So, if I'm a scientist and I come to you guys, for instance, and I say, where are you going to put your cameras if you want the best opportunity to find the bleaching? What would you guys say? Red, yellow, or green? Where's the best opportunity for me to see this thing? Red, absolutely, right? So, when I went to Australia, I put my cameras right here, thinking, well, data sets from the past, both 1999 2002, have told me that these areas are the really likely to bleach areas in Australia. So that's what I did. I put my cameras there, and this is what happened. Perfect, right? That's great science. And I mean that literally. Failure is an extremely important part of good science. In fact, if all of my cameras had just worked, the film would probably be pretty boring. You just want to watch some cameras, there'd be no emotions, there'd be no anger, there'd be no failure, there'd be no adversity. And that's what makes a good film, and it also makes good science. So instead of using these cameras, I had to bail on them, and I had to do it myself. I went down underwater. I spent about 6 hours every day at 25 different sites, taking 2 minutes of video at each site and watching this ecosystem die. And that was emotionally really challenging, but what we were able to do was really exciting. And for those that haven't seen the movie, this is a span of 55 days. This is one of the coolest reefs that I've ever been on, but you'll watch what happens as the water temperature increases. So that's what we call an ecosystem collapse, an ecological collapse. This ecosystem no longer functions as a coral reef. The majority of fish that live on a coral reef also are dying. Most of them absolutely rely on their coral partners for survivalship, but there are actually some winners during this. If you're an herbivore and you eat algae, you now have an unlimited supply. There's always winners during an ecological disaster, which is also pretty interesting. However, what makes a coral reef is now gone. These places will no longer be the same ever again, and we're seeing this all over Australia. So just how bad was this event? This event started in 2014 and went throughout 2017, and our first real large bleaching event actually happened in 1998, and it was because of what we call an El Nino. And I'm not going to get too far into the El Nino because it's really just kind of boring science that I don't think you guys are super interested in, but ultimately what it means is that temperatures get really, really high around the world and they push corals over kind of their threshold of heat they can take. So this is just to compare the first bleaching event that was recorded in 1998 and what happened through 2015 and 2016, but you can already tell there's a lot more red on the right? It looks a lot worse. And that's exactly what happened. And in fact, what you're seeing right here, if you look at Hawaii on the right, that big red patch is actually really novel. We don't see that in 98, right? We call that the blob. It's a very scientific term. And it's actually going to happen again. But before we get to the next slide, this is a really important thing for me to show people because throughout 2014 and 2017, this is a conglomerate map. It means that it's throughout time of what we call a bleaching alert area. Basically what that means is it's a way for us as scientists to look at the data and say what areas of the world might actually have some big issues going on underwater. And what you'll note on this graph is the no stress area. Do you see that anywhere on there? It doesn't exist. Over the past 5 years, there is not an inch of our ocean that did not have more warming that is too dangerous for corals to live in. And that's pretty disturbing, and that's why we do the work that we're doing. Now, I actually took this screenshot this morning. We talked about the blob, again, very, very scientific term. This is it this morning. We're actually already seeing 2 degrees warming in Hawaii for this bleaching season, which usually is October. And so Hawaii is going to bleach again this year, just 2 years after the largest bleaching that they've ever seen. So this issue is continually happening. We're going to talk more about the coral bleaching. I hope that you guys have questions during our Q&A panel. But now I want to really talk about some of the takeaways that I had working on this film. Again, I was a young kid that was thrown into this crazy world of filmmaking and science and diving. And I learned a huge amount, and that's why I go around and do things like this and talk to young people about what they can do into the future. And one of the most important things right off the bat is that your perspective on the world is everything, including even in our political world. Like, perspective is reality. for most people. And this image is my best example of why perspective is everything, because when you look at this picture, do you see anything but just a coral? Or is that just a coral? Just a coral, right? Maybe it's pretty, you could say it's green, maybe you can say it looks like a stick, but it's just a coral to most people. But my perspective is different. I work on corals for a living, and I work on classifying them as organisms. Well, this coral is really special to me because this is the first discovered coral in over 30 years. This is the only picture ever taken of this coral, and it's the only piece of this coral that's ever been seen. But you wouldn't know that, right? Because you don't have that perspective. But we can give people perspective using art, using film, using these means of communications for science, which is really cool. Because a place like this is extremely special. And again, you look at something like this and you think, oh, well, this is just a coral reef. Well, it actually turns out that this image is a picture of the most diverse ecosystem we think on the entire Great Barrier Reef. But you need the perspective to see some of these details. And that's also because corals, like I said, are pretty boring for most people. They sit on the ground, they don't do anything, they're really colorful, but outside of that, they do absolutely nothing. They're essentially rocks. However, if you manipulate the time, once again, like a glacier, you start to see them as animals. They have mouths, they fight with each other, they eat, they have sex, they kill each other. They're just like every other animal, but you have to manipulate your perspective and your way of time to really see the beauty of these creatures. And in doing that, we've actually brought corals to the forefront of the world and the news feed. We actually won the audience award for Chasing Coral at the Sundance Film Festival, which is a huge deal. It's like winning an Emmy, essentially. But we did actually win an Emmy as well. So it's all about getting these things out into the population. And the bridge between art and science is so incredibly important. When I started this project, my background is in science. Had you come into my office and asked me about art, I probably would have told you to get out. I didn't care. I didn't think it was important. I was that person that said, do art for art's sake. And I could not have been more wrong. Art and science are the most important bridge that we have about talking about these issues. Because art is something that we all can attach with. We can all appreciate a painting. We can all appreciate a video. We can all appreciate a photograph. And when you utilize those tools to make a difference, there's a huge amount of power behind that. Now, one of the other things that I learned was working with scientists from all over the world. And scientists get a pretty bad rap. They're not really allowed to be human. Science is forced to be objective. And we see things like this. After the bleaching event, we put things into buckets. We like to compartmentalize. And what we do is we say black and white. These are two different things that came out in the same week in 2016, and they have two drastically different headlines. One, you have the pessimistic side on the left, an obituary written for the Great Barrier Reef, which just simply isn't true. The Great Barrier Reef is in a lot of trouble. We've lost about 50% of the corals in the past 3 or 4 years. And then you have the other side. Everything's just dandy and fine. The reef's killer, everything's all good, but there's no in-between, there's no reality here. The Great Barrier Reef is made up of 4,000 or so individual reef systems, and not every single one of them has the same impacts. And to go even farther into that, to show you why this is important, that we don't just pile things into two different buckets of yes, no, black, white, it's all about the gray area. When I came back to Australia to document exactly how the reef had changed, it was up here in the far north. And what we wanted to do was compare the red areas with the orange areas. The orange areas we thought were going to be better off because they have access to cooler water. That inshore area gets really, really hot. And essentially that's what we found. Our hypothesis was right, but it's not the full story. So on the inshore, this is mostly what we see. Does this look healthy to you guys?
No.
I heard some yeses and nos. This is like 100% dead. There's like nothing living in this photograph. And it's on the inshore, and this is what we expected to see. And we continually saw that while we were on the inshore. And then we came across a couple places like this, also on the inshore. This is also one of the scariest dives that I've ever done. In Australia, we have crocodiles that get extremely large, sometimes 35 feet long, and they don't actually stay on the mainland. They swim around the Great Barrier Reef. You can find them as far out as like 15 miles. and they are absolutely terrifying. And this day we're diving on this incredible reef. There's like 5 feet of visibility. In the back of my head I was like, oh man, this is why my mom worries. However, then we go to the offshore, and this is where we found some of the most incredible places that I've ever seen. This is one of my favorite reefs in the world. Incredible diversity and still largely intact. This is actually a coral that's about, 30 feet tall, maybe 50 feet in diameter. And it actually has a miniature coral reef growing on top of it, which is pretty cool. However, even on the outside of the reef, we still find places that look like this, completely damaged, extremely difficult for an environment like this to be mediated into the future. But it really just goes to show once again that there is no yes and no's when it comes to science. Every individual reef has its own story, has its own impact, and we cannot group things together as yeses and no's. Now, not only is that true for the reef itself, it's also true for science in general. I'm a firm believer that in science, we don't actually tell the full truth of why we become scientists and what science is all about. I think for the most part, most people would think, when they think scientist, what do you think of? Because when I was your age, I used to think, scientist. White lab coat, maybe some beakers, some numbers, some data entry. And while those things are certainly part of science, that's not why we do it. I didn't grow up dreaming, oh man, I can't wait to go spin some beakers in the laboratory all day. That doesn't sound like fun. But it's what we're showing. We're showing serious faces all the time, working really hard. Even in the underwater photos, it's still somebody taking notes. All these things are important, but it's not why we're there. We're there because we love something. I love corals. Like, you want to talk corals? I'm like a little kid. I also know people that study slime. And you want to talk about slime with them, they'll be like little kids and they're going to get excited. It's endless what you can study, and as long as you have passion, that actually creates good science. What we're really doing is sharing experiences with each other in the field. We all care about something similar, and we're all able to share those experiences with one another, with passionate individuals. And this is why we do the science, because we get to see a 900-year-old coral and pose and swing our arms wide open and enjoy ourselves, or walk into the mangroves with a big smile on your face, even though you're still doing those things that are sciencey. And we also have fun days. Actually, in this day, I was on a boat for 31 days, and it was a lot of work, a lot of hard science, a lot of late nights, and not a lot of sleep. But every now and then you take a break. On this day, I got to go to Rain Island. Guess how many sea turtles I swam with on this day? About 6,400 massive female green sea turtles, all in the same island, in the same water at the same time. Incredible. And that was just our fun day, right? With 30 days of hard work, but you're still in the ocean, you're still in the elements with all of these amazing creatures. And every now and then you get a nice underwater high five. Those are the moments that we live for, not the breakthrough data. We live for this. And every now and then we get a slate that looks like this, which is also pretty awesome. Now, the last thing here is that hope is extremely important. And hope comes in 2 different forms. We have the science hope. Science is doing some really cool stuff on the coral reefs, and that's really important. But it's also the people hope, because the people back up the science. Now, from the science perspective, this is one of my favorite photos, because you can tell that the majority of these corals are dead. But that little surviving patch has a really important story to tell us. In surviving, it means that that coral had something different than everything around it. You've got essentially all of the death and one little patch. Why did that patch survive? That's the question we're trying to ask, and that's the question that's ultimately going to lead us to important breakthroughs for coral reefs. And that's exactly what we do. So last time I was out there doing work, I collected all of these surviving corals, and we brought them back to a laboratory, and the idea was, if I breed these 2 corals together who both survived the most damaging underwater event that's ever happened ecologically, then their offspring should have a better chance, right? If mom and dad both survived, the offspring should have a pretty good chance to have that same genetic material that helped them. And it's that type of science that's really exciting. And it's one of the ironies of, an ecological disaster is really cool research gets to happen really quickly. And the other portion of this is how corals reproduce. So coral sex is pretty sweet. They do some pretty interesting stuff. It's very different than us. This is a baby coral, for instance. That's no bigger than like a pinky nail. But here's the thing. Every single coral in the Great Barrier Reef reproduces on the same night. In November, on the full moon, every coral in the ocean throws their eggs and their sperm into the water column, and we're talking about trillions and trillions of baby corals now floating all over the ocean, and they can now go anywhere and replenish reefs that actually have been disturbed. In fact, coral's favorite place to land is on old coral. And in fact, these little larvae do something like a shimmy shake. There's actually videos of this. And that little larva will sit its little butt inside one of these dead polyps, and it literally does a shimmy like this, and wiggles its little butt into the hole, and now you've got a brand new coral. Now what they don't tell you, and I've been diving on some of these events where they're spawning, what they don't tell you is that when you're swimming around all night in a bunch of sperm and eggs, you don't smell very good when you get out.
Or they grow on you, just kidding.
Now, although the smell is pretty disgusting, and I think it's kind of funny, but this is one of my favorite pictures that I've ever taken. It looks pretty boring, but this is actually a photograph about the size of an iPhone. And what you're seeing here is 5 completely different species all growing in that small little area on one of the most disturbed reefs that I've ever been on. And this is important because even though a lot of the Great Barrier Reef has been damaged beyond any scale that we can comprehend, this is still happening. You still go back to these places a year later, and those babies that may have come from Indonesia or from a different reef are actually still there. And that's really, really exciting because these are going to become full-fledged corals, and they're able to replenish each other. However, all the cool science that we're doing is really all for naught unless we hold our end of the bargain. You guys are the most important thing and the most important source of hope that I have. I've been able to work with kids and youth for the past 2 years working with ocean-oriented projects, and you guys are really what keeps me going. You have been handed a plate that is really dirty and it's not your fault. I use the analogy of a party pretty frequently. It's like all the adults have been throwing a party for 100 years. You guys weren't invited, we trashed the house, and now you're invited to come help clean up, but the party's over. Now, cleaning up is something we have to do, absolutely. However, I don't want you to just focus on cleaning up the house. I want you to throw a better party. That's the most important thing. The other example is, hey, driving a Tesla is probably a lot cooler than driving a Honda Accord, right? We have to make things cool again, and you guys are the leaders in that. We already know that your generation obviously doesn't have a whole lot of money, but one day you will, and what we do know already is that you're willing to spend the extra dollar to support companies that value the same things that you do, which is really important. And you've been handed this situation that's really bad, and quite frankly, you guys have taken control of this all over the world, and the kids that I've met over the past 2 days are doing incredible work right here in your local community, and you have an unlimited amount of fantastic people with great resources here in your own neck of the woods that are doing amazing things that impact everybody's everyday lives. I know that you guys have been through a couple 1,000-year floods over the past 5 years. Whether or not you're protecting corals or turtles directly, you can participate within your community, and you guys are truly the leaders moving forward. And that's where the hope ultimately lies, whether it's through things like virtual reality or technology, or just simply picking up more plastic or using less plastic, all the way to utilizing art to bring these things full circle. And again, it doesn't have to be coral reef. It doesn't even have to be environmental. It just has to be something that is meaningful to here and now in your community. Every community has something different. There's no silver bullet to the issues we face, but every community can look inwards to itself. We can determine what we're doing well and what we may not be doing well, and we can try and make ourselves better. And that's extremely important. Tell your story. Everybody's got a story, and storytelling, again, is one of the most important tools we have in science. It's one of the most important tools we have in advocacy and activism. So everybody continue to do that. And always remember, even if you're not into science, let's say you're not a math person, you're not a science person, well, guess what? This film, for instance, it's not scientists, it's filmmakers, it's scuba divers, it's lawyers involved, accountants, people from all walks of life with various different skill sets. And whatever you end up doing in your life, you can actually take that skill set and apply it back to something that's meaningful to you. And I think that's what's the most exciting thing. Is you're not limited to something that may be lame or not exactly aligned with what you believe in. You can take whatever you do and wherever you end up and bring that energy back to something that's meaningful to you. And that's extremely important. That's really all I have for this part of it.